So right at the beginning, I'm going to make a table, and we'll talk about comparison of acids. There are three types of compounds that are considered acidic. So there's going to be, uh, so this is the first column. Okay, that should be sufficient. And you have, एक second. So four types of compounds that are considered acidic. The first one is alcohols. Okay, so that's ROH. That's the first one. The next one is, I'm going to put in water over here. Then you're going to have phenols, which are C6H5 and OH. And finally, the last one is going to be carboxylic acids. So it's going to be RCOOH. So we'll be comparing, water is just for reference. We'll be comparing all of these, and we'll compare their strength as acids. The first one is alcohol, sodium. They all react with sodium. Alcohols have a very slow reaction with sodium, but all of them they react with sodium metal. The next one is NaOH, and with NaOH, I'm actually going to not talk about water that much. And I have sodium carbonate. Only the carboxylic acid reacts with sodium carbonate. These don't. So water is just for reference. That is only there. We know that it reacts with sodium. And so that's only there as a reference because I wanted to tell you that when you have water, alcohols have a weaker acid strength as even compared to water. So when you move towards the right, you get stronger acids. Now remember, all organic acids are weak acids, but this is relative comparison of strength of acids. So alcohols are the weakest, and the carboxylic acid or any acid derived from carboxylic acid, that's going to be the strongest in relative terms. And remember this table. We're going to explain and learn what this table means. That they all react with sodium. All acids have three reactions, three main types of reactions. They react with metals, they react with bases, and they react with carbonates. So only the carboxylic acid is the one that actually kind of behaves as a complete acid that undergoes all reactions which normal acids undergo. So let's start with the first one, and that is why alcohols are the weakest acid. And they're so weak that they dissociate even less compared to normal water. So they have a lesser dissociation compared to water. So the dissociation is lesser compared to water. Uh, and what would be the dissociation? It's going to be that if you have an alcohol, the OH group is going to break away. And when it does, it would form O minus one ion and an H plus one. So this is what's going to happen when an alcohol dissociates, but it dissociates very, very weakly. It hardly dissociates. Okay, water dissociates very less. The amount of ions that it produces is 1 into 10 to the minus 7. Alcohol dissociates even less. compared to water. So, so if you have alcohols, most of it is not going to dissociate. I said, so why? What's the reason? You'll be asked why alcohols don't dissociate. And before that, let's write an equation for the reaction, and let's write the names as well. This is ethanol, and this would be called the ion that is formed. That would be ethoxide ion. And they only react, the only acid reactions that they have, they only react with very reactive group 1 metals. So one reaction would be that if CH3CH2OH reacts with sodium, so the H of the acid, the OH group, is going to get displaced by sodium. So it's going to become CH3CH2, O minus 1 and Na plus 1, and hydrogen gas is going to be produced. Okay. Acha, Sara, Ariba, is this clear?
Yes.
And even with sodium, the reaction is, it's going to be a very slow reaction. Only slight effervescence. Normally, sodium reacts explosively with acids. But with alcohols, it's a very slow effervescence, so only very slow or very slight bubbles are seen. So this is what's happening. And apart from this, there are no acid reactions. Alcohols normally don't dissociate that much. So what's the reason? The reason lies with the negative ion. Okay, so let's pick CH3, CH2O minus 1, which has dissociated and it has produced H plus 1. So why is dissociation not happening? So you have a carbon chain, and carbon chains have an electron donating effect. So if the negative charge over here on the oxygen, it's attached to a carbon chain, the carbon chain has an electron donating effect, the negative charge over here increases. And if the negative charge increases, the H plus 1 is not going to be breaking away. It would be attracted very strongly to the negative charge. So it all depends on the negative charge on this ion. So I'm going to write the explanation that alkyl chain in CH3CH2O has an electron donating effect. And which increases as it increases negative charge density on this ion, which makes it unstable. Okay, and by the word unstable, what that means is that the negative charge over here is going to be so strong because more electrons would be donated by the carbon chain. Okay, carbon chain has electron donating effect. The negative charge over here would be so concentrated that it's going to quickly attract the H plus 1 back, and the dissociation is not going to happen. So negative charge density on CH3, which makes it unstable and leads to lesser dissociation. ठीक है, क्लियर है ये अरीबा? सारा, is this clear?
Yes, sir.
Okay, the basic rule is about acids and comparison of acid strengths. The basic rule is the negative charge on the ion, if it's strong, then it's a weak acid. तो अब alcohols का थोड़ा आपस में comparison कि what would happen if you have another alcohol, ठीक है, let's say comparing alcohols. So let's try and compare alcohols. You might be asked to compare. Okay, which one is going to dissociate more and which one is going to dissociate less? So here are two alcohols. One has a bigger carbon chain. Okay, so let's say you have a bigger carbon chain and the other one has a smaller carbon chain. अब मुझे कोई बताए कि which one is going to be the stronger of the two acids, two alcohols? Which one is going to dissociate more? Any idea? Ariba, कोई idea? Sarah? One of them is methanol, the other one is butanol. But apply the same logic. Okay, let's say it dissociates, okay? The bond over here breaks. So this oxygen gets a negative charge, the H gets a positive charge, right? So let's assume that this alcohol has dissociated, okay? I'm going to break it apart, okay? And the same with this alcohol as well. That it dissociates and the H plus one has broken away. Okay. Ariba, यहाँ तक clear है? Sarah, is this clear?
जी सर.
तो अब बताना ये कि इन दोनों में से किसके ऊपर, मुझे खाली ये बता दो कि किसके अंदर इलेक्ट्रॉन डोनेटिंग इफेक्ट जो होगा वो ज्यादा होगा. मतलब इलेक्ट्रॉन्स कौन डोनेट करता था कि कौन सा ग्रुप था?
ये जो लॉन्गर चेन वाला उसमें इलेक्ट्रॉन डोनेटिंग इफेक्ट ज्यादा होएगा.
ठीक है, उसके अंदर इलेक्ट्रॉन डोनेटिंग इफेक्ट जो होगा वो काफी ज्यादा होगा क्योंकि वो बड़ी चेन है. इट हैज मोर इलेक्ट्रॉन्स. तो जितनी बड़ी चेन होगी उतना इलेक्ट्रॉन डोनेटिंग इफेक्ट वुड बी ग्रेटर. तो ये हम ऐड कर लेते हैं. Sarah, is this do you get this point?
No, not really.
You just remember it's basically you have carbon chains, right? I mean, all your molecules have carbon chains, right? What do carbon chains have? They have lots of electrons, right? I mean, carbon has 6 electrons. This carbon has 6 electrons, 6 electrons, 6 electrons. So that's a total of 24 electrons. And you add in the hydrogen electrons. That's a lot of electrons. So Sarah, do you get the point that this carbon chain has lots and lots of electrons, right?
Yes.
And let me total them. Okay, let me total them. It's 24 plus how many hydrogens? That's 3 6 plus 3, that's 9. So around 33 electrons, right? So think over here that there are 33 electrons over here. So when you have 33 electrons, the electrons would automatically get pushed on any group that's attached to it. Sarah, do you get this point?
Yes.
Achha, how many electrons do you have over here? That's carbon has 6 and hydrogen has 3, so that's a total of 9 electrons. So if any group is attached, the electrons over here are eventually going to get pushed. Okay, because there are lots of electrons in the carbon chain. So the point is, and you have to remember the effect of carbon chains. Okay, you have to remember this. Okay, carbon chains have an electron donating effect. Okay, remember it's always an electron donating effect. And the bigger the carbon chain is, the more would be the electron donating effect. So is this clear? Do you get this point?
Yes, sir.
So the point is both of the carbon chains have an electron donating effect. But this one is a bigger alkyl chain. I said this one is a bigger alkyl chain, which means
सर
the
जो मेथनॉल है वो ज्यादा सॉल्युबल होएगा क्योंकि उसका इलेक्ट्रॉन डोनेटिंग इफेक्ट कम है.
soluble या dissociate मैं कह रहा हूँ.
ज्यादा मतलब उसकी डिसोसिएशन होएगी.
हाँ, ज्यादा होगी क्योंकि इसका डिस्कस कर लेते हैं. मोर अल्काइल डोनेटिंग इफेक्ट है तो नेगेटिव चार्ज की स्ट्रेंथ क्या होगी? ज्यादा होगा. ठीक है, इट्स गोइंग टू बी अ बिगर नेगेटिव चार्ज क्योंकि electrons उधर से भी आ रहे हैं ना, they're getting pushed onto the oxygen. So bigger alkyl chains, more electron donating effect, higher charge density on. So there's going to be a higher charge density uh, on this ion, CH3, CH2, CH2, CH2 and O-1, ठीक है, on this ion. तो वो क्या करेगा, वो अनस्टेबल हो जाएगा, वो H+1 को वापस अट्रैक्ट कर लेगा, it's not going to dissociate. मतलब the H+1 is going to get attracted because the negative charge is stronger. ठीक है? Ariba, is this clear? Sarah, is this clear?
Yes, sir.
Yes, sir.
And on the other hand, the negative charge over here is going to be lesser because the electron donating effect is smaller. ठीक है? So you have a smaller. So you have a smaller alkyl chain, less electron donating effect. ठीक है? Because it's a small chain. So lesser charge density. So the negative charge over here is not going to be very concentrated. There are not a lot of electrons getting pushed on this oxygen. So lesser charge density on CH3. This is the methoxide ion, CH3O-1, making it more stable. So if the negative charge is lesser, it's not going to attract the H+1 that strongly. So making it more stable. So there's going to be more dissociation happening in the second one. So I'm going to add this, that this negative charge over here, -1, is actually smaller in size. And this one is, I said this one is larger in size. Okay, they're both -1. But this -1 has a very strong charge density and it quickly attracts the H+1. ठीक है? ये clear है सारों को? Abu Raira clear है? Mahfouz, is this clear? Aisha?
Yes, sir.
ठीक है, Sarah, do you have any other questions about this?
No, sir.
Acha, then you can also have electron withdrawing groups. Like I can compare it with let's say there's an alcohol, two alcohols. Let's do another comparison. There's one alcohol which is this one. It's C with hydrogens, and there is an OH group. And there's another alcohol with OH group, but there's one Cl. And let's say there's a third one as well. Take it right next door. There's a third one as well, which is OH, and there's a Cl over here and an H, and H. Okay, 3 alcohols. Well, and I'm going to mark them, okay, so you can clearly see this is Cl over here. The Cl over here is over here. Remember, Cl is very electronegative, and the first one has no Cl. Which one do you think is the most? It's going to dissociate the most out of these 3 alcohols.
Third वाला.
ठीक है, third वाला.
जी.
ठीक है, third वाला ही होगा. So in each case, the H+1 breaks away. ठीक है, the oxygen gets a negative charge. So O is -1, H is +1, और यहाँ पे भी ना there is O is -1 and H is +1. अरीबा, third वाला क्यों choose किया?
क्योंकि Cl इलेक्ट्रॉन विथड्रॉइंग है और वो जरा ज्यादा करीब है OH के, तो इसलिए.
Exactly.
और
So
जो सेकंड वाला है उसमें Cl थोड़ा दूर है इसलिए.
ठीक है, so
वो फिर सेकंड पे करेगा.
the Cl has an electron withdrawing effect. ठीक है, Cl is going to withdraw electrons. So the negative charge over here, -1, is going to be smaller. And if it's smaller, अच्छा, if it's smaller, so it would not attract the H plus one. So the H plus one would break away and go away. So there's going to be more dissociation. Uh, there is electron withdrawing effect over here as well in the second one. I mean, there's a Cl attached, but the Cl is much further away from oxygen in that case. Uh, so it's relatively bigger compared to the negative charge is relatively bigger. So it's not going to let go of the H plus one that easily. And this one, there is no electron withdrawing effect. I mean, there's only a carbon chain. ठीक है, carbon chain उधर भी थी, but this only has a carbon chain. So carbon chain has an electron donating effect. So instead, the opposite would happen, that the negative charge over here, -1 over here, would be larger. So this one is going to be an unstable ion. And it's going to have a strong attraction for H plus 1 ion. So it's going to have a strong attraction for H plus 1, and there's going to be less dissociation. And whereas this one, the Cl is very close and has electron withdrawing effect. It has electron withdrawing effect. Sorry, mic off हो गया. अच्छा, so this one Cl is very close and has electron withdrawing effect. तो इसलिए इसका negative charge is much smaller, which is why the H plus 1 is not going to be attracted that strongly. ठीक है. Is this clear to everyone? Abu Reza, is this clear? Sara, is this clear?
Yes, sir.
Yes, sir.
ठीक है, next one. We're going to talk about phenol now. अच्छा, we're going to talk about phenols now. ठीक है. Phenols are the one in the middle. ठीक है. The same concept would apply. Okay, if you have an electron donating effect, okay, I'm going to write the whole idea, which is, ठीक है, the summary is that if you have an electron donating effect, so electron donating effect makes the acid weaker. And vice versa, if you have an electron withdrawing effect, ठीक है, electron withdrawing effects, they make the acid much stronger. So the whole concept is this. ठीक है, I've explained to you what the background is. So coming back to phenols, okay, what's going on in phenols? Okay, phenol is this thing. As a phenol is this thing. So you have an OH and the H would break away. Okay, if the H breaks away, so let me draw the dissociation happening. So there's this OH and the H has broken away. H has broken away. What happens to the negative charge? Remember, because start ke andar we studied there are all these orbitals over here, p orbitals, which are overlapping to form this pi electron cloud. And the pi electron cloud density was actually very less. Okay, which is why you needed catalyst when you were doing electrophilic substitution, because the electrons were getting distributed for every pi electron, for every p orbital on carbon atom, the electron was getting distributed on both sides. So the electron density on benzene is very less. And benzene has an electron withdrawing effect. Okay, benzene has an electron withdrawing effect. What basically happens is, and what you're going to write in your exams is, the lone pair on oxygen in this phenoxide ion, जिसको अपना C6H5, you can write it as C6H5O minus 1. So the lone pair on this phenoxide ion, this oxygen ion over here, it eventually overlaps with benzene's pi electron cloud, and the negative charge gets more distributed. So the negative charge overall, uh, its charge density decreases, and it no longer attracts the H plus 1 very, very strongly. So that's the whole idea. That the pi electron cloud over here has a very low negative charge density because the electrons are very distributed. So oxygen's lone pairs, they also overlap with benzene's pi electron cloud, making the charge density over here even lesser as well. So lone pair on oxygen in peroxide ion C6H5O minus 1 overlaps with benzene's pi electron cloud, with benzene's pi electron cloud making C6H5O minus 1, the peroxide ion, unstable, or sorry, more stable. So it no longer attracts the H plus 1 that strongly. So hence there's going to be more dissociation. And there's going to be less attraction for H plus 1. Okay, so when you introduce a benzene electron cloud next to OH, the electron withdrawing effect makes the negative charge over here much lesser. Okay, its charge density is lesser, and the H plus 1 is no longer that strongly attracted to it compared to alcohols. So according to our table that we drew earlier, phenols have a lot more acidic reactions compared to alcohols. Alcohols barely had any reactions. Phenols are going to react with Na, and they're also going to react with NaOH. So there would be two reactions that phenols would undergo. The first one would be with Na. So what's the reaction of phenols with sodium? That with sodium, the H is going to get displaced, and it's going to get replaced by Na. that would result in the formation of the salt. Which is going to be sodium phenoxide. Plus H2 gas is going to be produced. And the other reaction that's going to be very similar is that the same thing would react with, so the same thing would react with NaOH. And you're going to get the same product, except that on the other side, H2, instead of H2, water is going to be produced. So there would be two reactions, one with Na, one with NaOH. That is what phenols would undergo. Plus, phenols are also going to have a lot of derivative compounds. So if there is an electron donating effect, a group that's attached to phenol that has an electron donating effect, then that would make the phenol uh, even weaker in acidic terms. So if electron donating group, and we've studied which groups were electron donating groups. There was CH3 and there was NH2. So electron donating groups like CH3 or NH2 will make phenols even weaker acids. So one example is that you have so let's say there's NH2 and there's your phenol over here, and the H breaks away. So the oxygen gets a negative charge and the H plus one has broken away. But what NH2 would do is, if you remember, NH2 was an activating group. The lone pairs would overlap, and that would kind of increase electron density overall in a lot of places, especially in the 246 region. So electron density is going to be higher, much higher, because of the lone pairs on NH2. And if there are more electrons, then the electrons from this side would eventually, the overall effect would be that the electrons are going to be pushed somewhat towards oxygen. Or the other thing might not happen, that the lone pairs of oxygen previously were overlapping, but now uh, the overlap would be lesser because the lone pairs from this side are also overlapping. So that means benzene would not have as much of an electron withdrawing effect. The electrons or the lone pairs on oxygen are not going to be withdrawn that much because the electron density is already very high, because electrons are being contributed by nitrogen as well. So that results in an overall electron donating effect of the NH2 group. And the negative charge density over here increases. It's higher. And if it's higher, it's going to attract or pull the H plus one back again. And it's not going to dissociate. ठीक है अब ये बात समझ आइए सारा is this clear?
Yes,
Yes,
sir.
sir.
ठीक है So just remember the same exact thing would apply which we studied earlier. If you have a group which has an electron donating effect, then it's going to be a weaker acid, and if there's a group which has an electron withdrawing effect, then it's going to be a stronger acid. Okay, that this pretty much summarizes, I mean, within alcohol comparisons and within phenol comparisons. So remember that. And similarly, if you have a withdrawing group, then that would make the acid stronger. One example is again you have OH. And there's an electron withdrawing group, like aldehydes were electron withdrawing. So they would withdraw electrons from the benzene electron cloud. And if the H over here breaks away, H plus one is going to be formed. So overall, the lone pairs overlapping with benzene, that part would increase because there's another group that's withdrawing electrons. So the benzene electron density would be lesser. So oxygen would start overlapping with oxygen's electrons would start overlapping, and that would make the negative charge over here. Its charge density is going to be lesser. And if it's lesser, it's not going to attract the H plus 1. Okay, the H plus 1 that has broken away, that is no longer going to be attracted as strongly, and that would lead to more dissociation. Okay. So we'll continue with this in the next class then. Okay. Quick question there, Sara. Is this clear? Ariba, clear?
Yes, sir.
Yes, sir.
चले ठीक है.
Okay, sir. Allah Hafiz.
Okay, take care. Allah Hafiz.